In the next section of the solutions worksheets, we take a look at redox reactions. In number 1, we're asked to identify the half reactions given by each chemical equation, and also to identify the oxidizing and reducing agents. On the AP exam, it's not likely that we'd be asked about oxidizing and reducing agents. Rather, we would be asked which substance was oxidized and which substance was reduced. So we're going to include that in our analysis of the problem. Letter A, I have a formation reaction or combination reaction between iron and oxygen in which iron 3 oxide is created. My 4 iron atoms will lose electrons to become 3 plus ions. It's a total of 12 electrons, and those 12 electrons are gained by the oxygen molecules to create 6 oxygen ions or oxide ions. Since iron is losing electrons, we say that it is oxidized. Oxygen gained electrons, it's reduced. If iron is oxidized, we would say it's the reducing agent, and oxygen is reduced, so it's the oxidizing agent. Again, we focus only on what's oxidized or reduced. In letter B, I have displacement of a halogen. My chlorine will have to gain 2 electrons to become chloride ions. My bromine ions will lose 2 electrons to become the bromine molecules. In this case, bromine is oxidized because it lost electrons. Chlorine is reduced because it gains electrons. The one that is oxidized is the reducing agent. The one that's reduced is the oxidizing agent. In letter C, I have another combination or formation reaction, this time creating a molecular compound, silicon tetrafluoride. I will use oxidation numbers in this one, and silicon's oxidation number goes from 0 to +4, which means that it lost 4 electrons. The fluorine's oxidation number goes from 0 to -1, showing that they collectively gained 4 electrons. Since silicon lost electrons, it's oxidized. Fluorine gained them, it's reduced. And again, our reducing agent and oxidizing agent are identified here. In the last reaction, I have hydrogen plus chlorine creating hydrogen chloride. My hydrogen molecules go from neutral to hydrogen ions, so they lose electrons. The chlorine molecule gains those 2 electrons. The hydrogen is oxidized because it lost electrons. The chlorine is reduced because it gained electrons. In number 2, we're asked to identify the oxidation number of phosphorus in several different oxyacids containing phosphorus. In letter A, I can look at the oxidation number of hydrogen as +1 and each oxygen as -2. Since there's 3 oxygens, that totals -6. The hydrogen is +1, so I have a -5. The oxidation state of phosphorus is +5 to add up to 0. In letter B, I have 3 hydrogens, each +1, and 2 oxygens, each -2. So I have a +3 and a -4. The phosphorus will need to be a +1 to balance that out to 0. In letter C, I have 3 hydrogens, each +1, and 1 oxygen, which is -2. So I have a -2 plus 3, that's a +1. Phosphorus must be -1 to balance that out. Letter D, each hydrogen is +1, giving us +3, and each oxygen is -2, giving us -8. +3 and -8 is -5, so phosphorus must be +5. Letter E, my hydrogens are +1, so that's +4 for all the hydrogen, and each oxygen is -2, giving me -14 for all of them. +4 and -14 is a -10. So each phosphorus must be +5 to balance out the -10. And in letter F, my hydrogens are +1 still, and my oxygen is still -2. So that gives me a +5 for hydrogen and a -20 for oxygen. Those will add up to a -15. So the phosphoruses must add up to a +15. There's 3 of them, so 15 divided by 3 is +5. In number 3, we're asked to give oxidation numbers of the underlined atoms. Letter A, well, fluorine is always -1, so the chlorine will be +1. In letter B, fluorine is still -1. That makes fluorine -7. Iodine must be +7. In letter C, methane, my hydrogens are a +1. That makes hydrogen +4. Carbon must be -4, and that should be a negative, not a positive for that one. And in letter D, C2H2, hydrogen is +2, so the carbons will be -1. In letter E, C2H4, my hydrogens are still +1, so that's +4. That makes each carbon -2. In letter F, potassium chromate, my potassiums are +1. My oxygens are -2. So I have +2 and -8. Chromium must be +6. And in letter G, potassium is still +1 and oxygen still -2. So I have a +2 and a -14. That gives me -12. So the chromiums will be +12. That's +6 for each one. In letter H, potassium permanganate, potassium is +1 and oxygen is -2. So that's +1 and -8. My manganese will be +7. In letter I, sodium bicarbonate, sodium will be 1+, hydrogen 1+, and the oxygens, each -2, will give me -6, so the carbon must be +4. Letter J, the oxidation number of any element by itself is always 0. Letter K, I have sodium iodate. Sodium is +1. Oxygen's -2, so that's -6. So +1 and -6 is -5. Iodine will be +5. And in letter L, I have a superoxide. Since potassium is +1, the two oxygens must be -1. That makes each one -1/2. In letter M, I have the PF6 ion. I have 6 negatives for fluorine, but phosphorus must be +5 so that it adds up to a -1. And in the last one, potassium gold chloride. Potassium is +1. The chlorides are -1, so that makes it -4, and +1 is a -3. So gold will be +3 to balance that out. The next question is about the activity series, and it asks which of the following metals can react with water. Gold, mercury, and platinum are 3 of the least reactive metals, so those will not react with water. The 2 that will are lithium and calcium. Lithium is high up in the activity series, so that will readily react with water. The calcium will react with water, but not as easily because it's a little lower on the activity series. And next question, we're asked to identify whether or not the reaction will occur by using the activity series, and then to write balanced equations for each. Letter A, I have copper reacting with hydrochloric acid. Copper generally does not react with acids, and its reactivity is much lower than hydrogen, so there will be no reaction here. Letter B, iodine reacts with sodium bromide. Iodine is the lowest member of the halogen family, which means it's the least reactive of the halogen family, so it cannot replace bromine, which is higher up in the activity series and higher up in group 17, so no reaction again. Letter C, I have magnesium, which is solid, reacting with copper sulfate in solution. Copper sulfate is in solution, it is soluble. Magnesium is higher in the activity series than copper, which is generally low in reactivity. So the magnesium will replace the copper, creating the copper element solid, and magnesium sulfate in solution. Now, creating a net ionic equation for this, my copper sulfate is soluble in water, as is my magnesium sulfate. So that makes sulfate a spectator ion. So I can also write this equation as magnesium solid reacts with the copper ion, and it creates the magnesium ion plus copper solid. The last equation, we have chlorine, which is above bromine in the activity series. So it will replace bromine, creating bromine and potassium chloride. Check your charges and check your coefficients to make sure it's balanced. And we could write this one as a net ionic equation also. Potassium bromide on the left and potassium chloride on the right are soluble. So that means the potassium ion is a spectator ion. So we could say that this reaction is the chlorine molecule reacting with two bromine ions to create the bromine molecule and two chloride ions. And then in number 6, we're asked to classify the redox reactions. Letter A is a combination or formation reaction. We have two substances that are joining together to create a more complicated substance. Letter B, we have a redox reaction where one substance breaks down into simpler substances, so that's a decomposition reaction. Letter C is a displacement of a halogen. It's also known as a single displacement reaction in Chem 1, but now we're looking at what type of displacement. All right, and letter D is a disproportionation reaction. If you look at the oxidation numbers of hydrogen and oxygen, they do not change in this reaction, but nitrogen changes from a +3 to a +5 in the first compound, which is nitric acid, and a +2 in the second compound, which is nitrogen monoxide. 7 asks us to identify which are redox processes, so we need to look at the oxidation numbers to see if they changed from left to right. In letter A, I have carbon dioxide. My oxygen's -2 in both instances, and the carbon appears to be +4 in both instances, so this is not redox. Letter B, both oxygens are -2, but the vanadium appears to have changed from a +6 to a +4, so this one is redox. Letter C, the oxygens did not change, nor did the sulfur, +6 before and after, so this is not redox. Letter D, the oxygens stayed -2 on both, but my nitrogen changed from a +3 to a +5. And last, letter E, I have the chromium 3 ion changing to a chromate ion. This one is also redox. Chromium starts as +3. After the reaction, it's +6.